For this next function, we're going to calculate f of x plus h minus f of x over h. If you remember from the previous page, we already did solve for f of x plus h. F of x plus h was equal to negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h. We've already solved that and evaluated that. Then we're going to subtract f of x. So now we're going to subtract f of x. Recall from the previous page, f of x was simply equal to negative 3x squared plus 2x. So this is my whole numerator. Then we're going to divide all of that simply by h. It is not f of h. F of h would mean something different. F of h would say plug h into all of the x's in the original function. This simply just says h. Alright, so now we're going to simplify things up here, and you'll notice things will start to cancel. So let me rewrite this by distributing the subtraction sign first. So I will rewrite this. So we have negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h. That becomes a plus 3x squared. That becomes a minus 2x all over h. So you're going to notice things are going to cancel at this point. Negative 3x squared and 3x squared. 2x and negative 2x. So the only things that are left are going to be negative 6xh minus 3h squared plus 2h all over h. Now remember, to simplify an irrational fraction, we want to take out as much as we can as that greatest common factor. So if I take those h's out in front as a greatest common factor, that will leave me with negative 6x minus 3h plus 2 inside. The reason I took out the greatest common factor is because now you'll see that those h's can now cancel. So this completely simplifies down to negative 6x minus 3h plus 2. This is actually called the difference quotient. The difference quotient is something that you'll see a lot in calculus. You do not need to memorize this. If you are going to be asked this on a college algebra exam, it will be given to you, but you will need to know how to simplify and get to this answer down here. So let's find one difference quotient for this particular f of x. Now remember, the difference quotient is equal to f of x plus h minus f of x over h. So this is what we need to solve for. So the first thing we do, just like we did in the example above, let's first determine what f of x plus h is. So we take x plus h and we plug it in for x. So it becomes negative 3 times x plus h plus 2. So f of x plus h, all I did was take x plus h and plug it in for x. Then we're going to subtract f of x. F of x, well, that's already written. F of x is this whole right-hand side. So we're going to subtract negative 3x plus 2. Then we're going to divide all of that by h. So let's simplify. This becomes negative 3x minus 3h plus 2 plus 3x minus 2 over h. You'll see that the negative 3x and the 3x will cancel. The 2 and the negative 2 will cancel. So I'm left with negative 3h over h. The h's will cancel, and this whole difference quotient reduces down to negative 3. You'll find a lot of the times in difference quotients, a lot of the numerator and also a factor will generally cancel. So let's move on to finding the domain of a function. The domain of f is the largest set of real numbers for which the value f of x is going to be real. In order to find the domain, start with all real numbers, just like we did back in Chapter 1 when we talked about domain. Always start with all real numbers and then make any exclusions from the domain if there are any. There are two exclusions that we need to be thinking about. If there's a denominator, denominators cannot be 0. So you cannot divide any number by 0. So that would mean 0 cannot be in the denominator. If x was in the denominator, x could not be 0. Another thing is radicals. When we have an even radical, an even index, like 2, the square root, we cannot take square roots of negative numbers. Everything underneath the radical has to be 0 or more, has to be a non-negative number. This has to be non-negative. So those are going to be the two things that we're going to look for as far as exclusions are concerned from our domain. So let's look at 3 examples. The first example I have is f of x equals 2x plus 3. Notice there are no denominators and there are no radicals, so therefore the domain x can be any real number. There are no exclusions. For part B, I do have a denominator. Denominators cannot be 0. This cannot be 0. So if I take the square root of both sides, that gives me x cannot be 0. So we would exclude 0. So there are two ways we can write this. The formal way to write this notation would say that x can be any number x such that x is not 0. This is one way to write it. Another way to write that would be an interval notation. If we were to write this in interval notation, I would write any number as long as it's not 0. So that means it could be any number from negative infinity to 0, or it could pick right back up at the other side of 0 and go to infinity. But I had to exclude 0 in the middle. So you could write the domain either way. And for the last one, again, I have a denominator. Denominators cannot be 0. So we state that this denominator, x squared plus 1, cannot be 0. So let's subtract 1 from both sides and take the square root. You're going to see the square root of x squared cannot be, oh wait, square root of negative 1 is impossible. There is nothing actually excluded. There are no exclusions because this is actually not possible. There is no x that will ever give me 0 in this denominator. How is it possible that anything squared, any number that I put in here, when I square it, how will that ever be negative 1? That is impossible. Anytime you square a number, you'll always get a positive. So this is an impossible thing to do. So that means no matter what x I plug in, I'll always get a positive value down here, which means it will never be 0. It's impossible to make this 0. So therefore, x is all real numbers. In interval notation, we would show that as negative infinity to infinity, which I could have showed up here too. Okay, on to the last page. We're going to do a few examples and find some more domains. For part D, it's asking me to find the domain of this rational expression. So what I do first is I look at the denominator and make sure it is not 0. So I set the denominator not equal to 0. So how do we solve this quadratic? In the past, we have factored the left-hand side, set it equal to 0, and then we can solve each one independently. If we were to factor this, you'll get x minus 3 and x plus 1. So that means each of them independently, that means x minus 3 cannot be 0, x plus 1 cannot be 0, so that means x cannot be 3, or x cannot be negative 1. So I actually have two exclusions. So my domain, I would say x is any number x such that x is not equal to negative 1 or 3. In interval notation, I would state x can be any number negative infinity to negative 1, or negative 1 to 3, or 3 to infinity. That's another way to write that. Over here, we have a denominator, but we also have a square root. So everything under the radical cannot be 0, but also everything underneath this radical has to be greater than 0. So all of this in the red box has to be greater than or equal to 0, because we cannot have a negative underneath an even root. You can't have that would indicate a complex number. So we only want real solutions here. So real numbers means everything under here has to be not negative. But at the same time, I have to also exclude 0, because 0 cannot be in a denominator. So we simply just say x plus 4 is greater than 0. By subtracting 4 from both sides, I find x is greater than negative 4. So my domain is any number x such that x is greater than negative 4. In interval notation, we simply would just say if x is greater than negative 4, we would start at negative 4. We would not include it, and we would go to infinity. And finally at the bottom, we're trying to form the sum, difference, product, or quotient of these particular functions. So if I wanted to add two functions together, I could do it separately, but I could write it as f plus g of x. You're adding these two functions together, both of them are being evaluated at x. The same would be true for subtraction, multiplication, and division. So we simply just multiply them together or divide them. So looking at these examples down here, for the functions f of x, which is 2x squared plus 3, and g of x, which is 4x to the third plus 1, I'm looking for you to find f plus g of x. By definition, f plus g of x is the same as f of x plus g of x. So I simply just have to add f of x plus g of x. So I'm going to add 2x squared plus 3, and we're going to add to that 4x to the third plus 1. So let's combine any terms that might be alike, just the 3 and the 1. So that's going to give me 4x to the third plus 2x squared plus 4. So now when I subtract, I take f of x and I minus g of x. So I do the same thing I did for plus, but I change the plus sign to subtraction. So it becomes 2x squared plus 3 minus 4x to the third plus 1. So you're going to notice I'm going to need to distribute that negative sign. So my first term is going to be negative 4x to the third plus 2x squared Then I have 3 minus 1, which is 2. Then when we multiply, we take f of x and we multiply that by g of x. So we take f of x, which is 2x squared plus 3, multiply that by g of x, which is 4x to the third plus 1. So this becomes a FOIL problem. When I FOIL this, I get 8x to the fifth plus 2x squared plus 12x to the third plus 3. I might want to consider writing this in descending order of power, so I will write 8x to the fifth plus 12x to the third plus 2x squared plus 3. And for the last one, f over g of x is the same thing as f of x divided by g of x. So I plug f of x in for the numerator, I plug g of x in for the denominator, and then I simplify. This is not factorable, this is not factorable, so therefore that is my answer.